task number 9, question number 1. So we can see that after reading this question, we need to identify the domain and the range of both f of x and g of x. Now g of x is a transformed function of f of x. Let's first focus on function f of x. I can see it's a degree 2. Degree 2 would insinuate that this is a quadratic function. The domain of any quadratic function is all real numbers. What does that mean? It means there's no limit what I plug in for x values. Now the range depends on whether the parabola opens upwards or downwards. And to figure that out, we're going to look at the a value, or the leading coefficient. Because that leading coefficient is positive, I know this parabola opens upwards. To identify the range, I know that there's going to be one point that is the lowest on this graph. And once I'm able to identify the y value of the lowest point on the graph, I can then identify the range. So how do I identify this ordered pair? Well, first we're going to start with the x value, and you do need to know this formula. The x value of the vertex of the parabola can be determined by first identifying the a, the b, and the c. So in this problem, a is 2, b is 6, and c is -1. Let's plug in now 6 for b and 2 for a. So x equals -6/4, and whether you substitute that down, use a graphing calculator, we can see that 6 divided by 4 is in fact equivalent to 1.5, or -1.5 in this case. So that means I would be going over here to -1.5, and now we need to know where's the y coordinate of this. So to figure out the y coordinate, we're going to go back up to this equation, and wherever I see an x value, I'm simply going to plug it in. So I have 2 times -1.5 squared plus 6 times -1.5 minus 1. And that's what f of x, also known as like our y value, will equal. That's going to be the y value of this vertex. So I'm going to grab a graphing calculator, put it off to the side here, and let's make our life a little bit easier by plugging this in. Make sure to use those parentheses. And we can see it is at -5.5. So just a rough graph, what does this look like? There's 1, 2, 3, 4, 5, 5.5, -1.5. It'd be something like this going up. Okay, so if you're a visual learner like myself, we can see I just did a rough graph. Here's this vertex. Again, it can be found at the ordered pair -1.5 and -5.5. That's going to come into play when we talk about this next function. So let me write that down. -1.5 and -5.5. Again, in order to identify the range, we need to know the y component of the vertex of the parabola. So this parabola, the lowest it goes is it goes down to -5.5, and we include that because we have a point with a y value of -5.5. But the arrows insinuate that there is no limit how high it goes as it goes up to the right and also up to the left in that diagonal motion. Now let's look at the second part of this problem, which is definitely a little bit more complicated. Remember, our end goal ultimately is to identify the domain and the range of the function g of x. Now the function g of x is just a transformed function of f of x, so it still remains a quadratic, which means I already know the domain of g of x is going to be -infinity to positive, because there will be no limits in what I plug in for x values. The range is a little more complex. In this particular problem, we can see we have a vertical shift of down 4 units. So we are transforming f of x into g of x. And so what we're going to keep in mind is that in order to identify the range, I need to know, let me take this really quickly, what's going to happen. It's the y part of the range that matters. And so here I can see that we are going to vertically shift this down. So the function g of x is transformed by f of x by pushing it down 4 further. So this point is going to go down 4 further. So let me subtract 4 to get -9.5. -9.5. That's the y value of this. Now, in a horizontal dilation, you're either going to have what's called a horizontal stretch or compression. You learn about that in 9th grade, and we bring it up again in Algebra 2. And when that happens, what happens is the y values remain the same, but the x values change. And so in this particular case, we have a horizontal dilation, or for this problem, we have a compression of 1/3. So what we're going to do is we're going to take this value and we're going to multiply it by 1/3. So negative 1.5 times 1/3. And that will give us the transformed x-coordinate of the vertex of g of x. So feel free to grab your calculators. I'll do that right now. Negative 1.5, and really when we take it times 1/3, it's just dividing it by 3. That's the same thing, but negative 1.5, and if you want to put it in parentheses, you can. And you can see we end up with negative 0.5 or negative 1/2. So I know what this looks like. I still have the same basic shape, right? The same basic shape. It's been pushed closer to the y-axis and it's been pushed down further, but still that same basic shape. So it's the quadratic function has a parabola that opens upward, and this is its vertex. So there is no limit how far it goes to the left or right, but the range goes down, we're looking at the y value, as far as negative 9.5, and there is no limit how high up it goes. Let's practice a few more like this. One from task 9, we're going to practice a few more like this to build your confidence. I'm looking at the function. I'm not told it's quadratic, but I can see that it is degree 2. What does that mean? It means the highest exponent on a variable is 2. So degree 2 is quadratic, which means I'm going to have either a function that's a parabola that opens up or a function that opens downwards. I know that there is no limitations on the domain of a function. So the domain is negative infinity to positive infinity. And now I'm going to use this formula, x equals negative b over 2a. And so the b in this case is a negative 2, so 2 negatives will make a positive, and then 2 times a, we don't see a number in front, it's really hidden 1. So this gives me 2 negatives is a positive, 2 times 1 is 2, so I get an x value of 1. Now I need to plug that back in to figure out what is the y value of the vertex of the parabola. I do know that this particular function is going to open upwards because the a value of this quadratic function, or the leading coefficient, is positive. So I'm going to plug in 1 really quickly, and I could do mental math, but I think this will even speed things up for me. I have 1 squared minus 2 times 1, subtract 24, and I get an answer of negative 25. If you're a visual learner, it's somewhere way down here, and it's opening upwards. So this is 1 and negative 25. Okay, so the range is going to use this y value. This is the lowest point, and it is included on the graph of the function, and there's no limit how high it goes. Now let's go over to the more difficult part, when we have to describe the domain and the range of g of x. Again, g of x is just a transformed function from this original quadratic. So again, the domain is negative infinity to positive infinity. Now I'm going to write down what the vertex of this previous parabola was. We can see that in this function we are vertically shifting down 11. So I'm going to take negative 25 and subtract 11, and that gives me negative 36. And then I'm going to take the x value, and we have a horizontal dilation. It's being compressed here. And I'm going to take it times, let me go back up here, times 1/5. So I'm taking 1 times 1/5, which is 1/5. And I could put a 1/5 here. I know, and you can plug into your calculator, that 1/5 is equivalent to 0.2. So this is going to be the vertex, the coordinates of the vertex of the parabola. It still opens up. It still opens upward. And so if I think about that, it's going to be right about here and way, way down here. And so looking something like this, very ugly sketch of that, but the general shape of it looks like this. The lowest it goes would be negative 36, and there's no limit how high it goes. In this third example, I see again we have degree 2, so it is quadratic, but notice that the a value is not positive. So now I'm going to have a parabola that opens downwards. So I still need to find out what are the coordinates of the vertex, particularly the y coordinate is what I'm looking for, but there's going to be no limit how low it goes. All right, let's get started. Because it is a quadratic function, we have the domain of negative infinity to positive, and then I'll use this formula, x equals negative b over 2 times a. So x equals negative 8 over negative 4, x equals positive 2. That's the x coordinate of the vertex of this quadratic function. Now, how do we figure out the y? I'm going to grab my calculator to make life easier for us and plug it in, making sure to use parentheses. There's 2 squared plus 8 times 2 plus 5, and we end up with 13. So this is the coordinate of 213. This is the coordinate 213. So in this case, when I do the range, notice we do it the smallest to the largest. The smallest would be negative infinity. And it goes all the way up as high as a y coordinate of 13, and it is included on the graph of the function. Let me write the coordinates for the vertex of f of x. Now, g of x is going to be a transformed function, and we can see here that we do have this horizontal dilation. So to the y coordinate, we are going to add 6. We're going to vertically rise that up to 19. So the coordinates for g of x of the vertex, 19 will be the y coordinate. And now let's figure out what the x coordinate is. I'm going to take the 2 and multiply it by 1 over 2. 2 times 1 over 2, well, 2 times 1 is 2, 1 times 2 is 2, and that's going to simplify to 1. So I have 119. So when I do the domain, because I do know that this is just a transform function from a quadratic, the domain will remain negative infinity to positive. Now the range, we still have a function that opens downward, but we're going all the way up to 119. So there's no limit how low it goes, but it goes as high as 19, it's included. And our fourth and final example, to mimic question 1 from task 9, I'd like you to look at the next example, write it down, press pause, try it on your own, and then come back and see, did you correctly? This is the fourth example I'd like you to write down, attempt it on your own, then press pause on this video and come back. So I'm going to do less right now with explanations, but we can see it's degree 2, and so I know that the domain for f of x and even the transform function g of x would be negative infinity to positive. Now I'll turn it away here, by the way, if you have a graphing calculator, and if this is a part where you can use the graphing calculator, would be to actually go ahead and degraph this function. So 3x squared minus 6x plus 12. I'm going to graph it, and I want to know what is that point, the ordered pair for the vertex. I know this is a problem that opens upwards way up here. Looks like I do maybe want to raise it up a little bit higher so I can see it first. But I want to know the ordered pair right there for that vertex. Second trace, go down to minimum, the lowest point, and I'm going to go enter, enter, and enter. So we have 1, 9. So 1, 9 is going to be the ordered pair, and it's the y value that's going to help me here. We can see we have a minimum point of 9. We include that, so we're including 9, and there's no limit how high it goes. How can I use 1, 9 to come up with the range of the transformed function? We can see that we are going to vertically raise this up by 2, so it's going to go up to 11. Now the x part of the coordinate for the vertex will be taking this 1, and then we're going to multiply it times 1/3. 1/3, by the way, is equivalent to 1.3 repeating, so this is going to be the coordinates of g of x for the vertex of this parabola that opens upwards. So it's going to be as low as 11 because it opens upwards and no limit how high it goes.